Welcome to Chapter 14. In this chapter, we're going to get into some of the basic rules of probability and also some counting rules. And in this first section, we're going to answer the question, how good is Mrs. Soto at shooting free throws? If Mrs. Soto is not your teacher, then you can ask the same question about your math teacher. Anyway, we're going to assume that your math teacher thinks that she's a pretty good free throw shooter. She is claiming that she can make 80% of the free throws that she attempts. And so, what we want to know today is how many free throws would we have to watch in order to determine if Mrs. Soto or your math teacher actually was an 80% free throw shooter? So, in other words, how many shots would we have to watch before we could feel pretty confident in making a guess at what her true ability is? Now, you'll have a link to a free throw applet, which you can play around with if you'd like, but I'm going to show you the applet in this video. Okay, the applet looks like this, and we are going to just shoot one free throw at a time and look at the results and then also make a graph of the results as we go. Let me hide this a second here. All right, so we'll shoot the first time. And notice that I made that first shot, and so my percentage is currently at 100% because I'm 1 for 1. And it's hard to see on the graph, but we could put a little dot up here at 100%. Now I'm going to shoot a second time, and now I made that second shot, so now I'm 2 for 2, so I'm still at 100%. This horizontal blue line at 80 is my claim. So right now I'm well above my claim. So we'll shoot a third time. Now I'm 3 for 3, so I'm still at 100%. And at this point, you may be wondering if my claim is true, and maybe I'm actually more than an 80% free throw shooter. As we are going, by the way, you can be filling some of this in your notes. So for example, this is how I would write that in. I would say for shot number 1, result, make or miss. I'm going to put a check there because I made that first shot. And then at that point, I was 1 for 1, which would be 100%. Sorry for the bad writing. Now, the second one, I made that shot as well, so I was still at 100%. 3 for 3, I'm at 100%. Now, if at some point I miss a shot, you could put an X there and then fill in the corresponding percent. So let me clear this off and we'll go back to the applet. Okay, so I've shot 3 times. Let's shoot a fourth time. 4 for 4, 100%. Oh, but now I missed the 5th shot. So notice that my overall percentage dipped down quite a bit. It went from 100 down to 80% because I'm now 4 out of 5. Now in your chart, it jumps from 5 to 10 shots. So I'm going to change the number of shots here to 5 because I want to shoot 5 at a time just real quickly so I don't have to wait. So I'm going to shoot. And now it's going to do 5 right in a row. And notice that I've missed a few there. So when I get to the point where I've done 10 shots, now I'm at 8 for 10, which is again 80%. Notice for a little while there, I dipped below that 80% mark that my claim was. I'll shoot 5 more. And now notice after 15 shots, I'm now 12 for 15. But again, during part of this time, I was below the 80% and then it kind of went back up. So still at 80%. So shoot again. Now I kind of got on a little bit of a streak there. So now after 20 shots, I'm at 17 out of 20, which is at 85%. Now I'm going to go up by 10 shots. So we'll do 10 at a time. Again, kind of climbing back up there, kind of a little bit of a streak. Oh, now dipping down. All right, and after 30 shots, I'm at 24 out of 30, which is 80%. Shoot 10 more. Now, after 40 shots, I'm at 31 out of 40, which is only 78%. We'll do a few more. And your chart goes up to 80, but maybe before we get to 80 shots, we'll be able to get a pretty good estimate at what my percentage is. All right, after 50 shots, I'm at 39 out of 50, which is 78%. I think I'm going to change this, and I'm going to just add on 30 more shots there so we can see where I am after 80 shots. I notice that that line kind of goes up and down, but at some point it sort of seems to level out. And my line actually kind of is leveling out close to 80%, which is what my claim was, right? After 80 shots, I was at 63 out of 80, which is 79%. And that's still pretty close to the 80% claim. When you're doing something a repeated number of times, like flipping a coin or shooting free throws, A lot of times you'll notice big up and down spikes at the beginning of the experiment, but then as time goes on, your line will kind of start to level out towards some value. And if I click show true probability, notice I have a green line that kind of appears there at about 75%. So it's likely that if I did more shots, I would end up at a value that's closer to 75%. Remember, back at the beginning, I was pretty close to that 80% claim with a small number of shots. But then as we're shooting more and more, the line is kind of starting to dip a little bit below that 80% mark, and it probably would if I shot even more. In fact, I'm going to put in there 100 more shots, and I'm going to have it run through 100 shots, and I'll just pause the video while it's doing that and then show you the results when it's done. All right, this is what the graph looks like after 180 shots, which was 100 more than where we stopped last time. And notice that after 180 shots, my overall percentage is at about 76%. So again, back at the beginning, we have these big up and down spikes. And then as time goes on, the percentage that I made through shooting kind of tends to approach what my actual true ability is. Okay, so in your notes, you can just make a quick sketch of that graph. Don't worry about the number of shots label on this horizontal axis. But anyway, for question number 4, it's asking us, how could we make our guess more accurate? Well, I did up to 180 shots, but we could potentially do 500 shots or maybe 1,000 shots. And I'd be willing to bet that with that many attempts, that many free throws that we're shooting, that it would get probably right at 75%. So watching more attempts always gives us more information than just watching 5 or 10 shots. So in this case, they told us in this, when we ran the applet, that I had a 75% chance or 75% probability of making a free throw. So how would we interpret that? What we would say there is that if I attempt many, many free throws, I will make about 75% of them. Now, when we say many in statistics, we're talking thousands, not just 100 or maybe even 500, but we're talking like many, many, like thousands of free throws. And when that happens, we know that the performance we observe should get close to the theoretical ability of the athlete. So probability is, we typically think of that as the chance of something occurring, but in statistics, we like to think about it as the long run relative frequency. In other words, it's what happens in many, many trials of an experiment. So if you flip a coin 2 or 3 or 4 times or even 10, you probably won't get 50-50 heads and tails. But if we tossed 1,000 times, you would expect your results to be a lot closer to 50-50. Now, what the law that dictates that is something called the law of large numbers. And the law of large numbers tells us that if we do something many times, the proportion of desired outcomes will approach its probability. Again, with a coin toss, we expect coin tosses to be 50-50, but nobody is surprised if we toss a coin 2 times and both tosses land showing tails. But if we tossed a coin lots of times, let's say even 100 times, we would be very surprised if 90 out of 100 tosses came up showing heads or tails. We expect it to be a lot closer to 50-50 if we do many, many coin tosses. We know that events are unpredictable in the short term, but predictable in the long term. All right, for example number 1 in your notes, it says, the probability of an archer hitting a bullseye on a target is 9%. Interpret what this probability means. What that means is if the archer attempts many shots at the target, he will hit about 9% of them. Example number 2, a basketball player is a 50% free throw shooter. In the last game, he attempted 7 free throws and he missed all of them. The coach tells the player that he is much more likely to make the next shot. We want to explain why the coach is wrong. Well, we're assuming, again, that each shot is independent. So if a basketball player truly is a 50% free throw shooter, then it should be 50% for each shot. And it doesn't matter what happened on the shot before that or even 7 shots before. So his overall percentage of shots probably won't get close to 50% until he takes many more shots. It doesn't necessarily mean that he's more likely to make the next shot, but if he were to shoot many, then we would see closer to the 50% that we expect. All right, there is no assignment for section 14.1.